My name is Louis Galuzzi,
I'm Stephen Fu.
and today we will be talking about ownership in Rust. There are three primary rules of ownership in Rust. One, each value in Rust has a variable called an owner. Two, there can only be one owner at a time. And three, when the owner goes out of scope, the value will be dropped. Rust has both types and literals, and ownership differs slightly for both. String type. String types are immutable by default, but have the ability to become mutable by adding the keyword mute. In this example, we assign string value hello world, and then set string 1 equal to string. Because ownership dictates we can only have one owner at a time, when we try to print out string, we will get an error telling us the value has been moved.
String literals. String literals can only be immutable. In our example, we have variable string assigned to hello world. Then we have variable string 1 assigned to string. Ownership doesn't apply to literal strings due to them being immutable because of their fixed size. This allows us to use the stack memory instead of the heap. This makes string literal types less expensive and faster, but at the cost of less flexibility. In our example, we are able to print out string because it doesn't go out of scope.
Give and take. Just like with types, when we pass our variable as a parameter to another function, we transfer ownership from main to give take. In order to allow main to print string after calling give take, we set string equal to the return of give take. Give take returns string 1, which is the current owner of hello, and gives ownership back to string in main, hence the give and take relationship.
Borrowing. Borrowing is a feature that Rust developers developed to fix the issues of having to give and take every time we pass ownership. Borrowing is accomplished by passing a reference to the original variable. In our shown example, we have string type variable string assigned to hello. We pass in the reference of variable string to borrow, which prints it, and pass it in that reference to borrow2, which prints it again. Ownership is still maintained in the original string variable, which is shown in our print statement in main after the borrow function is called.
Mutability and borrows. Because borrowing does not take ownership from its original variable, it is important to restrict what can change the value of string. When we attempt to allow both string 1 and string 2 to borrow the value from mutable string, we end up creating a race condition. To avoid this, Rust enforces that only one variable can borrow from a string within the same scope.
Dangling pointers. In our example, we show how a dangling pointer can occur in Rust. In our main function, we assign variables string to give. In give, we create a string type variable that is assigned CSC372. We output variable string and return the reference to it. The problem is the variable string goes out of scope when give function finishes, hence it returns an invalid reference. This can be solved by returning the variable string to main, which transfer ownerships to the string variable in main.
We implemented anagrams in two different ways, one using string types and one using string literals. In anagram, we ask the user for input. We can type hello world, and then world hello with extra spaces. Main passes in the two inputs to anagram function, which transfers ownership from main to anagram. Anagram removes white space from the inputs and then sorts based on byte values, then prints whether or not they are anagrams. We could have passed in inputs as a mutable string, which would have let main retain ownership. Or we could have used the give and take pattern and returned the inputs to main, but main in this case no longer needs access to the inputs, so simply transferring ownership is sufficient.
In anagrams 2, we hard-coded string 1 to hello world and string 2 to Lodor hello with a few extra space characters in between both words. Both strings get passed to anagrams 2 function, which creates a character array which sorts the characters and trims the space characters from both strings. It then compares the two and outputs true or false. Notice how we do not have to deal with ownership in this particular case due to string literals being stored in read-only memory.